Now we'll be discussing surface tension. Surface tension is a fluid property which mainly occurs because of the molecular cohesive force, and we know that molecules consist of molecules. Between the molecules there are two types of forces are exist. One is molecular cohesion force and adhesion force. Molecular cohesion force is the attractive forces between the molecules of a given substance or same substance, whereas the adhesive force is the attractive forces between the molecules of a unlike materials, means different substances. So molecular cohesion's force is more strong in solids. Therefore, it is very difficult to have a relative information in solids. So, and it is lesser in liquids and then again lesser in gases. So, for gases, it also depends on thermodynamic state like pressure and temperatures. And so now we'll come to the surface tensions. So this molecular cohesion force in a liquid which exhibits a fluid property, that is surface tensions. Let us see how it exists. Okay. So consider a bulk mass of fluid. Consider a bulk mass of fluid. So in this bulk mass of fluid, 1 minute. Okay. We are discussing about surface tensions, and this cohesion force in a liquid that defines a fluid property called surface tension. Let us see how the surface tension will exist. So consider an example of a bulk mass of liquid which is separated from the air. This is air is in at the top. The interface which separates the air and liquid. Okay, this is the surface that will be called as free surface, and the bulk mass of the fluid. Let us consider molecule A, which is present at a certain depth. So this molecule A is attracted by the surrounding molecules, and if we see the from the statical theory, the average attractive force between the molecules towards the molecule A is zero. A is 0. So the molecules A is attracted by the neighboring molecules by the cohesive force, and these molecules are attracted which are not far away. Only nearby molecules are attracted by the nearby molecules. So generally, the distance between the molecules, which is 2 to 3 times between the two molecules, so therefore, we are considering a sphere of influence here. So within the sphere of influence, the molecules are attracted towards the molecule A. So towards the center of A. So here we see the molecule A is in balanced position because the forces, the molecules present on the upper and downsides are equal. Okay, downsides are equal. There, 1 minute. Okay. So the molecule A is attracted by the nearby molecules which are in the sphere of influence. So this is in balanced definition because the molecules on the upper side and on side are same, are equal. So consider another molecule B. So therefore, here also we consider another sphere of influence. Within the sphere of influence, all molecules are attracted by the cohesive force towards the molecule B, and in the same way, consider another molecule C, which is at the interface. So definitely, we are having here net inward force because more molecules are present on the downward sides, and therefore resultant force is downward sides. And here no force is present. This is also not true, but here force is not by the cohesive force. Here force exists is on the top side existed by the adhesive force. So means that the air exerts the adhesive force onto the liquid. And so how the surface tension exists. So here interface we are having. On the interface, if you want to extend the surface of the free surface, then a mechanical work has to be done. So mechanical work has to be done. Means that these molecules travels near to the surface. So means that the coercive forces are becomes lesser and lesser. Then the these molecules travels to the near to the surface, and if we see this surface which is to be seen as under stretched conditions. So from the top, if we see this surface along the linear directions in both the directions, we are having forces per unit length. That is nothing but a surface tension. Surface tension is means what? The forces per unit length. Okay, here two important points we have to notice that surface tensions occurs only at the interface, and one more point is that surface tension is not property of liquid. It is a binary property. It's a property of liquid and air. Okay, this is about surface tension. Okay, thank you.